Hello Yetan. This is the second lesson on converting between units. This lesson covers the work on pages 470 to 471. Okay. In summary, from last lesson, I've talked about the idea of if you have similar shapes and we had a length scale factor of n, the area will have a scale factor n squared and the volumes will have a scale factor of n cubed. So in this lesson we're just going to go through about 5 examples of working with this idea. Okay. You might want to pause the video and have a go at each question and then check as I go with me. Okay, so 2 similar parallelograms here. We're given the area of each of those, okay, and then we're asked to find the length. Okay, so in this case we've got the area scale factors we can find by doing 45 divided by 5. Therefore, the length scale factor must be the square root of the area scale factor. Because remember, if the length scale factor is n, then the area scale factor is n squared. So if we're given the area scale factor, then we can get the length scale factor by square rooting it. So the square root of that is 3. So the lengths must be increasing by a factor 3. Therefore x must be 2 times 3, in this case 6 centimeters. Okay, so again, pause the video, have a go. So in this case we're going to get the volumes, so we can work out the volume scale factor. So that divided by that. So we can find the length scale factor if you cube root the volume scale factor. Okay, so in this case we're essentially given n cubed here, so n cubed is 8, and therefore n, the scale factor, must be this, which is 2. Therefore y, the height of this, has to be 20 multiplied by 2, which is 40 centimeters. Okay, example 3. Again, pause and have a go. So we've got Duncan bought a toy that grows when placed in water. Before placing the toy in water, it was 4 centimeters tall. After, it grew to a similar shape toy which is about 10 centimeters tall, and we asked whether the claim is reasonable. Okay, so here if you compare just the lengths, so we can find the length scale factor by comparing the lengths, which is 5 halves or 2.5. If you compare the areas, that will be the square of this. So the square of that, which is 6.25, and if you compare the volume, you get 2.5 cubed, which is 15.625. So based on these measurements here, we've got they claiming that it grows 10 times larger, but looking at it, comparing areas, it grows 6.25 times as big, but comparing the volumes, it grows 15.625 times as big. So we can say, in terms of the volume it has grown, 15.625 times. Therefore, the claim is reasonable, although slightly inaccurate. Okay, so it's important that for a worded question we have a worded response. Okay. Question 4. So I took this from an old exam question. So you've got A and B, that's mathematically similar. You've got the ratio of surface areas is 4 to 9. So we know in terms of area, solid A to solid B is in the ratio 4 to 9. All that means is for every 4 units, in this case square centimeters in A, there are 9 square centimeters in B. So we asked to find the volume of solid A. Actually, we asked to show the volume of solid A is 120. Okay, so we know, first of all, we can find the lengths ratio. So the length ratio is the square root of the area ratio. So square root of 4 is 2, square root of 9 is 3. So the lengths of these two shapes must be in the ratio 2 to 3. So the volumes is going to be 2 cubed, which is 8, and 3 cubed, which is 27. So the volumes are in the ratio 8 to 27. So as a scale factor, then the volume scale factor from A to B, A on to B, must be 27 divided by 8. Therefore the volume of solid A has to be the volume of solid B divided by the scale factor, which is 120 cubic centimeters as required. Okay. And finally, going through the example in the book, we've got a similar case. We've got volumes that are given to us of the two similar shapes, and we are asked to find the surface area of Q given the surface area of P. Okay, so we're going to go through the same, compare the volumes. So the volume scale factor is this divided by this. It's about 3.375 if you wish. So the length scale factor must be the cube root of the volume scale factor. So cube rooting each of these is going to give you 3 over 2 or 1.5. So we want area scale factors. So area scale factors is the square of the length scale factor, which is 9/4. So to find the surface area of Q, we're going to do the surface area of P, which is given to us, multiplied by the area scale factor, which is 549 square centimeters. Hopefully that's enough for you to have a go at the exercises on exercise 22.2a. Okay, good luck.